it's a project that a lot of people really enjoy. So, okay. All right, so here we go. These are our parent functions, and we are going to apply these transformations. Do you remember from the previous stage? We have 4 transformations that are taking shape. Yes, the vertical shift is what you will do first. What after that? Amplitude, period, and horizontal shift. So, as I look at the worksheet that I made for you today, we will do 2 examples together, and then you will have time to work on your own. Let's first identify the vertical shift. What is the vertical shift? 1. And the amplitude? 2. So therefore, what I do is I mark off my vertical shift, which is 1 unit. And then using my amplitude, I'll mark off my maximum value and my minimum value. If I have an amplitude of 2, how high will it go after a shift of 1? It'll go all the way up to 3. And then, thank you, Sam, it will go all the way down to -1. The period I identify by, well, any questions on how I got those 2 pieces? Okay, which part? The vertical shift is the number on the end. The amplitude is the number, the absolute value of the number in front of sine. So then what I do is I go 1 plus 2 to get 3, and 1 minus 2 to get -1. I go 2 up and 2 down. Better? Good question. Thank you. All right, so we have those. The period I find by taking 2 pi, and I divide it by whatever number is in front of x. What number is in front of x? 1. So, right? Okay, thank you. 2 pi divided by 1 is 2 pi. So my period is 2 pi. I will divide that into how many parts? 4 parts. So 2 pi, pi, and pi over 2. We will count to get Hannah's result, which is 1 pi over 2, 2 pi over 2, 3 pi over 2. And I'm also going to sketch it in the opposite direction. Is there a horizontal shift? Yes, there is. Before I sketch a horizontal shift, I will sketch a ghost graph because it's difficult to sketch the horizontal shift without seeing the graph ahead of time. So we'll draw a dotted graph and then go from there. Where does this start? The max or min or the middle? Because sine starts in the middle. Will it start by going up or going down? Because it's positive, it'll start going up. At pi over 2, what will be the height of the function? It will be up to 3. Then it will do what? Go down to 1, and then after that down to -1, then up to +1. And I can do that in the opposite direction as well. That's my shape. Is that the actual graph? No, I'm simply using that to sketch the graph that I want. The graph that I want, I'll draw in blue. The horizontal shift is what? I take the inside and set it equal to 0. Yes. Sure. So x minus pi over 4 is equal to 0, so x is equal to positive pi over 4. How much is pi over 4 compared to a tick mark? It's half of a tick mark, because half of pi over 2 would be pi over 4. So I'm going to take all these special points that I marked, and I'm just going to move them over half of a tick mark. And once I move everything over half of a tick mark, I then draw the real graph. Is it plain and evident to you that the blue graph is the same as the green graph, just shifted over to the right pi over 4 units? To anybody internally, does that say to you, hey, that's actually kind of cool? I mean, that you can do that. I think it's pretty impressive, especially considering that that wave models the way that light travels to your eyes, models the way that um, a sound travels from my voice to your ear. So waves are essential to understanding the way the world works. Okay, waves on the ocean. Sure, go ahead. All right, last one, and then you have time to work. Vertical shift, -2. Amplitude. What is the amplitude? +2. So my vertical shift will be down 2. B. B is the number in front of X. Okay, so that's where the function is going to kind of oscillate around. What is going to be the biggest value that this graph will be able to get to? 0. Because if it shifted down 2 units and it goes up 2, that would bring you to 0. And if you went down 2 units, that would bring you to -4. So -4 is the bottom and 0 is the top of this function. I'm halfway there. Now I identify the period. Two pi over 3. I mark off 2 pi over 3, and I divide it into how many parts? 4. 1. What's half of 2 pi over 3? Half of 2 pi over 3, which is pi over 3. Think half of 2 pi over 3 will be 1 pi over 3. What is half of pi over 3? I take pi over 3, I multiply by half. I get pi over 6. Let's count. 1 pi over 6, 2 pi over 6. What is 3 pi over 6? Pi over 2. And I'm going to put that same mark on the other side. Which one are you looking for? -2 pi over 3, negative pi over 2, negative pi over 3, negative pi over 6. Is there, true or false, there is a horizontal shift? True. Before I sketch that, I must sketch the ghost graph. Does cosine start at the max or min, or does it start at the middle? Max or min? Is it going to start at the maximum or the minimum? Why? because it's negative. So I will start down at -4. And at pi over 6, what will the height be? -2. Then at pi over 3, what will the height be? 0. Then at pi over 2, back down to -2, and then 2 pi over 3, back down to -4. So I will go in reverse direction, the other way. And I will make my gentle little sketch. You told me there was a horizontal shift. How do I find the horizontal shift? Set the inside equal to 0. So 3x is equal to -pi divided by 3. X is equal to -pi divided by 3. What's different about that horizontal shift compared to the other ones we've seen? It's negative. So instead of moving to the right, I move to the left. How much of a shift is pi over 3? How many tick marks? 2. So I'm going to take all these points. I'm going to start with this one. I'm going to move it back 2 tick marks. Take this one, move it back 2 tick marks. Watch, you guys. If you just move 2 of them, you can get the pattern from there. So I'll move this one back 2 tick marks. Move this one back 2 tick marks. I don't even need to move them anymore. I can just now continue in my pattern, can't I? Top, middle, bottom. Then middle, top, middle, bottom, middle, top. So you can, once you figure out a couple of them, you can just continue on in the pattern of the behavior of cosine. And that's the graph. So we've shifted these all around. I think it's pretty impressive we can do it. Cass doesn't think so. She'd rather be on a beach. That's fine. It's fine. A beach would be a great place to learn trigonometry. So there are 2 more problems on this side, and there's 6 on the other side. Folks, you have 24 minutes to use your time. I'm going to hand back some assignments. Please make sure that you are focused during this time. I made this worksheet this morning, so no, I do not have an answer key yet, but I will produce one as soon as I possibly can. Okay.